Okay, a 20 microfarad capacitor and a 1 kilo ohm resistor are connected in series. A battery of EMF 12 volt is connected across the series combination. Determine the current at the instant when the battery is connected and current starts to flow in the circuit. And then amount of charge at time 10 millisecond, and the time taken for the charge to increase to 35% of the maximum charge. Good. Now, you need to detect, is this charging or discharging process? Yeah, this question is about charging or discharging process. Yeah, is it charging or discharging? Because the equation different. So look carefully. You say we have capacitor, resistor connected in series, and then a battery. This is the keyword. A battery is connected. Okay, before that is not connected. The battery before that is not connected. After some time, the battery is connected to the capacitor and resistor in the series. Then only the current starts to flow. Okay, then only current starts to flow, and then then the charge increase, isn't it? Charge increase. So this is about charging process. This is about charging process. Because you need a battery. You need a battery to charge up the capacitor. So this is about charging process. So we are going to use a formula on charging. Yeah, charging. So we don't look at the discharging process. Yeah, we look at charging. Okay, so now we need to extract the information. We have these capacitance, okay, of capacitor. Yeah, C. We also have resistor in series, 12 volt battery. I can say this one will later become the maximum voltage of the capacitor. This is the V0. Because this battery will charge a capacitor until it becomes same voltage as the battery. Understand? Okay, let me draw out this circuit for you and see. Okay. Let me draw it out. We have this capacitor. How to draw? How to draw? Let me draw it out. Okay, just draw it like this. I have maybe okay. Let's draw the battery. Yeah, at the top. Yeah, we always draw the battery at the top. And then we have the capacitor. We have the resistor. Okay, all in series. You see that? Yeah, all in series. So this is the battery. Okay, before that is disconnected. Yeah, before that is, I can say how to draw. Like maybe it's open switch here. You see that? Later you connect it. You close the switch. Yeah, and then yeah, I just want to draw this again. Okay, after that is connected. Yeah. Okay, this is the battery. Okay, we have the battery. Battery with the voltage of the battery. The voltage of the battery is 12 volt. Okay. You close the switch. Okay. You close the switch, and then the current will start to flow to charge up the capacitor. Yeah. So initially, at time equal to 0 second, the voltage of the capacitor is 0. Understand? At 0 second, the voltage of capacitor is 0. And this is the resistor. Okay. And then what to say? Okay, I can also put the voltage of resistor. Voltage across the resistor is 12 volt. Okay, voltage across the capacitor is 12. Voltage across the resistor is 12 volt, but voltage across capacitor is 0 volt because it's neutral, no charge. Yeah. And then initially this is when at 0 second. This happened at 0 second. This happened at 0 second. And then okay, initially this one also maximum current. Yeah, maximum current flowing. Okay. Then this capacitor has 0 voltage, but resistor has the maximum 12 volt from the battery. Yeah, because we know this thing. Yeah, we know that the voltage of battery is equal to voltage of capacitor plus voltage of resistor. Understand? Yeah. All right. So since battery is 12 volt, capacitor is 0 volt, so the resistor take up all the voltage. You understand? And this is what happened. And then after some time, okay, maybe at time t, yeah, at time t. So this battery voltage 12 volt. Okay, this 12 volt. Then in the end, no more current flow. Zero current becomes 0 ampere already. And then the voltage of capacitor now becomes same as voltage of battery, which is 12 volt. Become maximum voltage. Become V naught. You understand? Become V naught. It become V naught. And then the resistor voltage of resistor becomes 0. Because why? Because now capacitor take up all the voltage from battery. We can write like this. Also. Voltage of battery equal to voltage of capacitor plus voltage of resistor. So this 12 volt battery. So now capacitor take up all the voltage 12 volt. So now resistor has become 0 volt. Because also no more current already. Stop charging already. Yeah, the capacitor now has been fully charged. Positive, negative. Understand? It's already being fully charged. So that's why no more current. So resistor also becomes 0 volt. Why? We can say IR. Yeah, the current becomes 0, right? So that's why it becomes 0. Understand? The current becomes 0. No more current flowing. So no more voltage across resistor. This is what happened. Okay. So this charging process happened. Yeah, charging process happens. Yeah, from 0 second to t second. So initially the voltage is 0 across capacitor. Finally, the voltage of capacitor become maximum V naught 12 volt. All right. So this 12 volt is actually, we can say, the maximum voltage of the capacitor at the end of time. Okay, it's the maximum voltage of capacitor later on, 12 volt. So all right, now determine the current at the instant when the battery is connected and the current starts to flow in the circuit. So what I can say is the current at the instant. Current at what instant? Current when this is the current when 0 second. What's the current at 0 second? Understand? So we know that at 0 second the current is maximum. The current is maximum. Yeah, current is maximum. After finish charging, then only the current becomes 0. Initially the current is maximum to charge the capacitor. It's just like the example I told you before for charging process. At 0 second, this one at 0 second, it's like the current is like the water being poured in. After finish charging, only the current becomes 0. Initially, to start charging, the current pour in, a lot of water going in. So it's maximum current at 0 second. Understand? Maximum current. So how to get this maximum current? Let's find it out. Yeah, let's find it out. So question A, we want to get at 0 second what is the current? What I can say, this current is maximum. This current is maximum, but how to find this maximum current? So, well, we have the resistor, isn't it? Resistor, why is it this VR equal to 12? Why is it this VR equal to 12 volt? Because he take up all the voltage from the battery. 0 plus 12 become 12. Yeah, capacitor is 0 voltage, resistor is 12 volt. So we can say that like that. We can say the voltage of the resistor is equal to voltage of battery at this moment. Yeah, from here, what I can say, which is 12 volt. All right, 12 volt, and I can say that this is I naught R, maximum current. Yeah, V equal to IR, right? V equal to IR, so equal to 12. See that? I can also put this as V naught lah. Yeah, maybe you can write this as, you can write this as V naught. Yeah, you can write this as V naught. V naught equal to I naught R. If V naught, then I naught R. Understand? I can write like this also. V equal to IR. So I can find my I naught. So resistor I have 1 kilo ohm. 1 kilo ohm. So it's 1000 ohm. 1000 ohm. So 1000 ohms, and voltage is 12 volt. All right. So I can find my current. So how to find what's the current? 12 volt divided by 1000. So it's 0.012 volt. Ampere. That's my current. Okay. Voltage of resistor equal to voltage of battery. That 12 volt actually is the maximum voltage. That's the maximum voltage for capacitor later on also. 12 volt. Yeah. So that's why you can put this V battery as V naught. Because that's the maximum voltage. Yeah. So for maximum voltage, we can find the maximum current. Yeah. Current at this point is also maximum current. You see that? Maximum current. Maximum current. Maximum current. Okay. So so the current that passing through the resistor is also I naught lah. Is I naught. So that's why you put I naught R. Okay, so we got the maximum current already. That's the answer, 0.012 ampere. That's correct. Okay, so let's move on to question B. Question B, I'm singing, yeah? Okay, question B. What is the amount of charge? Okay, we want to find the amount of charge at this time, at time equal to 10 millisecond. Be careful with the unit millisecond, yeah? So when time equal to 10 millisecond, so what is the charge? So we can know this is a charging process, isn't it? We have a battery there to charge up the capacitor from neutral to maximum charge, right? So this is a charging process. And we're going to use formula for charge. This is about charge, yeah, not other thing else, yeah, not other thing. So it's charge, about charge. So what formula going to use? We're going to use formula for charging. I'm going to use a formula for charging, charge. Okay, so I always remember this rule. I write down again this one. Let me write it down again. About this one, copy this one over here. It's the same thing. I repeat so that we remember after I repeat. Okay, this one I can throw off. All right, so not this one, not this one. Okay, so which one? We know that we have charging and discharging process. For charging, the charge voltage increase, the current decrease. For discharging, all decrease. So we're going to use which one? We're going to use the charging. We're going to use the charging process. We're going to use the formula for charge because it mentioned about mentioned about charge, isn't it? And then increase. We know that in charging process, the charge increase. So increase is 1 minus E. It's not E, it's 1 minus E. So the formula is 1 minus E instead of E. You understand? So you're going to use 1 minus E. Okay. So for charging process, the charge increase. Then we write the Q naught. And then what to write at over here? Because charge increase means use 1 minus epsilon. 1 minus epsilon. All right. So here we write 1 minus epsilon. Okay. And then what else? And then we put negative T over RC over here as usual. Important thing is 1 minus epsilon. 1 minus epsilon because increase use 1 minus epsilon. Okay. Okay, so we settle. We got the formula already. We just substitute the value. Do we have Q naught? We don't have Q naught, so we need to find out what is the Q naught. How to find out Q naught? Just like we find. Oh, hold a second. Okay, so right now we can see that this finally the final charging process. After the charging process, this capacitor will charge up to maximum voltage, right? It will charge up to maximum voltage because the voltage increase, right? So it will charge up to maximum voltage. It will also charge up to maximum charge. The voltage of capacitor, the capacitor will have maximum charge, Q naught. Yeah. This I becomes 0, I decrease becomes 0, but the voltage become maximum. See that? Voltage become maximum. The charge also maximum. The charge also increase to maximum. The voltage increase to maximum. The charge also increase to maximum. Only the current drop to 0. Stop. Then only you stop charging. Yeah. So the charge will go to maximum. Voltage also go to maximum. So we can find the Q naught from V naught. You understand? So okay, how to find Q naught from V naught? Use the formula Q equal to CV. You need the Q naught first. You see that? You need the Q naught first. So you need to find Q naught first. Q naught is equal to CV naught. Q equal to CV. Q naught equal to CV naught. Just like you find the current, you see, if you want to find the current, you use V equal to IR, or V naught equal to I naught R. If V naught, then you have I naught. Understand? If you have V naught, you have I naught. If you have V naught, you also have Q naught. You have V naught, you have I naught. If you have V naught, you also have Q naught. Like that lah. Okay, so alright, so this one C. What is a C? What is the capacitance? Capacitance is 20 microfarad. Yeah, 20 microfarad. Okay, 20 microfarad. Micro is exponent, negative 6 farad. And then voltage, V naught. What is the V naught? V naught is 12 volt lah. Because the capacitor will charge up until it becomes same voltage as the battery, right? 12 volt. So finally the capacitor also become 12 volt, same as battery. But the resistor will drop to 0 volt. Yeah, because no more current flow. Okay. So all right. So let's calculate the Q naught. First, Q naught exponent negative 6 multiply by 12. So I got 2.4 exponent negative 4 coulomb. Yeah, it's a coulomb only because farad and volt all SI unit. So I got coulomb also lah. Yeah. Okay, so I got the Q naught ready. And then one more thing is, I do have R and C. I don't have time constant, right? But I have R and C, so I need to substitute into here R and C. So a lot of things to write there. Never mind. So let's do it slowly. Q equal to Q naught. Let's write it down. Q naught is 2.4 exponent negative 4. 2.4. Yeah, 2.4 exponent negative 4. And then 1 minus exponent negative t. T. Time is 10 milliseconds. So this one you need to change to second. This one is exponent negative 3. Milli is exponent negative 3. So be careful with the unit, yeah, or SI unit. So it's 10 exponent negative 3, yeah, milli, exponent negative 3 second, divided by okay, we divide by what? Resistor. Do I have resistor? Resistor is 1 kilo ohm, so I have to change to SI unit. So exponent 3, yeah, kilo exponent 3. 1 oh, what is this? So 1 exponent 3 ohm, 1 exponent 3 ohm, okay, and then multiply by capacitance. What's a capacitance? Capacitance is 20 microfarad. 20 micro is exponent negative 6. I change to SI unit also. 20 exponent negative 6. 20 exponent negative 6. Okay, seems like I got a lot to write here. I got a lot to write. Yeah, I got a lot to write. So, okay, make a divider. Okay, so let's calculate step by step. So I think I need to calculate the top one here first. Yeah, calculate step by step. 10 exponent negative 3 divided by this 1 exponent 3, and divide again 20 exponent negative 6. Okay, so I got, oh, half is it? So it is okay, I need to write again 1 minus exponent negative 1 over 2. I got this. And then let's calculate the answer. So 1 minus epsilon to the power of negative and half. All right. Okay, and then multiply by 2.4 exponent negative 4. Okay, the answer is 9.44 exponent negative 5. Okay, so column, that's the answer. That's the charge at 10 millisecond. Am I right? That's right. Okay, that's right. So 9.44 exponent negative 5. Column. That's right. Okay. So, okay, now find C. Yeah, C. Let's do the C. Question C. Yeah. So, what is the time taken for the charge to increase to 35% of the maximum charge? Okay, so, okay, now he asked for what? Asked for time taken. That means, what is the time? What is the time when charge increase to 35% of the maximum? Maximum charge is Q naught. Understand? It's Q naught. So that means the question is what is when is the time when what is the time when the charge is increased to not increased by increased to 35%. So become, or we can say become 35% of the maximum charge. So when is the charge become increased to 35%? So which is 35, the charge becomes 35% of the maximum charge. So what is the time when the charge increased to 35% of the maximum charge. This Q0 is maximum charge. So 35% means 35 over 100. 35 over 100. Yeah, 35%. Or change to fraction is 0.35 Q0. So when is the charge? When is the time when charge becomes 0.35 of Q0? So this is a charging process. Okay, so this is a charging process. I think I need to write. Where should I write? Yeah, so I need to write. This is a charging process, and we are looking at charge, isn't it? We are looking at charge. What's the formula? We know that for charging process, the charge increase, the charge increase. So what to write? Increase means 1 minus epsilon. 1 minus epsilon, yeah? Write that, yeah? 1 minus epsilon. Increase means 1 minus epsilon, okay? 1 minus epsilon. And then the rest is the same lah. Negative T over RC. Okay, so right now the charge, okay, is 0.35 or maximum charge. Write that down over here. Okay, and then bracket 1 minus epsilon. I need to find time, right? I need to find time. RC is they're just the same thing. Okay, RC. This RC, I don't want to write so many things. This RC actually is the time constant, right? Is the time constant. Time constant. Okay, let's calculate first the time constant. Yeah, out of here, time constant is 1 times time constant is RC lah. Okay, R and C. So I got the RC over here. See that? The RC, this is the RC. Let's calculate, and what is the RC? What is the RC over here? Let's calculate. Yeah, RC 1 exponent negative 1 exponent 3. Yeah, 1 exponent 3 multiply 20 exponent negative 6, which is 1 over 50, 0.02. So this is 0.02 second. So I just write here below as 0.02 second, yeah, to make things easier. Okay, I don't write so many numbers there. Okay, so I can cut the Q0. Q0 can be cancelled. And then one more thing is this 1 go to the other side. Becomes what? It becomes 1 minus 0.35 equal to what? Yeah, 1 go to the other side. Wait. Am I wrong? No. I think I need to exchange a bit. Okay. Okay. After this being cancelled, this minus exponent, this one I exchange place with 0.35. I exchange place with 0.35. This one and this one. Okay. 0.35 go to here, and then negative exponent go to the other side. So it becomes exponent negative T over 0.02 over here. All right, become positive already. Yeah, this one negative exponent become positive, and then 0.35 positive become negative. Yeah, so it become 1 minus 0.35. Understand? Which is 1 minus 0.35. 0.35 is 0.65. And then along both side, this one will go to the beside there. Yeah, go to the side along both side. Along the 0.35 also. Okay, remember this one become 1, and ln 0.35 is equal to this one is equal to negative what? Negative 0.43 078. Okay, 43078, and then here is negative t over 0.02. So my time is, so this will multiply negative 0.02. So my answer is 8.616 exponent negative 3 second. That's my time when the charge become, 35% of the maximum charge. That means it's like, this is the time when your handphone has charged with 35% battery. 35% battery. So when it's become 100%? When is it become 100%? So that is a meaning lah. Yeah, there is a time when the charge become 35% already. 35%. So is the answer correct? 8.616 exponent negative 3. 8.62. 8.62 exponent negative 3. Negative 3. That's correct. Yeah, that's the time. Okay. So that's how we do it. Yeah. Very easy question. So I hope you understand my working. Yeah. See you in the next video. Bye bye.